Hello and welcome to my next tutorial. Today we are talking about subsurface scattering. And this tutorial is not really about a specific render engine or a specific tool. We are talking about the core principles of subsurface scattering. So no matter with what render engine you're rendering your images, you should be able to follow along, since this is like those parameters there in all the materials out there that we can create digital materials for it. So to start with, let's do a quick recap of how our materials work. We can put them into three big categories. We have the first category where the light bounces off the surface in a certain way. So for example, if we have a metal that is very glossy, very shiny, then it will be a very strong reflection, so it's going to bounce off very straight. Or if it's more like a wood, for example, then it will be spread a bit more around, so it's going to be a bit rougher. Then we do have materials where the light is going to be partially reflected, but it is going to enter the surface, maybe bounce a bit around, but eventually is exiting the surface again. This is, for example, a liquid or a glass. And then we have our today's topic, we have the subsurface scattering. So with the subsurface scattering, we have again a volume, and the light hits the surface and is going to enter the surface and is going to bounce around in the surface and eventually exit the surface. Depends on the thickness of our object. It can also exit partially on the other side, but it's also going to exit here again. So these are our three types we can put in, or our three categories where we can put in our materials. So let's have a look here on the parameters that we see on material. So we want to turn the weight all the way to 100% of subsurface scattering. There's not really a material where you have a certain percentage of diffused mixed into it or metal. I would say if you know what you do, if you understand the parameters here, then you know how to use them, and then you can in a controlled way cheat certain materials together that are maybe physically not that accurate anymore, and then you can potentially mix in a bit of diffuse to it. But if you don't know what you're doing, if you're still just learning, which is absolutely fine, I would highly recommend to set this value to 1. So the color parameter is as simple as it is. It is really just the color. So we see here, this is now just getting darker. So it's just not doing anything else. It's just the color of our material. So the radius color is a bit more trickier one. So when we have our surface again here, this is the surface, and the light hits the surface, and subsurface scattering, it starts to entering it, we can control how different colored light rays are going to enter our surface and how deep they are going in. So as the name supplies it, we can determine the different radius of those light rays. So for example, with the R, G, and B, we can say how deep they should travel into our surface. This is important when we create materials where we have certain way of absorption of the different wavelengths, for example like a skin, or also for example teeth. There we're going to use that. Then we have the scale. The scale is just a multiplier of the radius values. That means technically we could just do everything with the radius numbers. We can just overcrank them and go just with a value of 2 or 3 or very tiny values, but there we need to manage three different numbers, which we'll see then in just a bit when we do a bit of a more practical example, which is very inconvenient. So with the scale, we basically can an overall amount of how strong we want to have our subsurface scattering effect. Then with the anisotropy is easily explained a bias. So we have the light hitting the surface and now entering the surface. When we have it set to 0, the light is just going to bounce around here inside very randomly, and it's just going to eventually leave the surface on one or the other side. When we set it to a negative value, then what is going to happen, I mean, it's much more complex than what I'm going to draw here because it's a light simulation where the light is going to bounce around, but the light is going less deep and it will exit our surface way quicker. when we set it to a positive value, the light is going to travel much deeper and eventually leave our surface again. So we bias the light rays inside of our volume into a certain direction to be less deep or deeper. This is how you can imagine it. So negative value, less deep, positive value, deeper effect. 0, it's just going to be random. Let me get rid of that. Okay, so now that we had a broad talk about the values itself, let's have a practical look on it. So for the color, obviously we plug in here the color. So this could be a tileable. This could be, for example, your texture you have painted for your candle or your skin or whatever material you're doing. This is where your color texture is going in. So for the radius color, let's assume we want to make a skin. We have there 3 different methods. Method number 1 is we switch to an RGB swatch, and now we can say the red should go in very deep. So we leave it, for example, at 1 or 0.9. Then the green should go in less deep, 3.5, and the blue should go in not so deep, so 0.2. And then we already start seeing here, we get this somewhat bloodier look here, where we can mimic how we have the different skin layers, where the blood layer is quite deep. So there's, that's why we set it here to the radius color, where the red is traveling in very deep. We also have a different method, which I like to use usually. We switch it here to HSV, where we define here the hue color, which is 13, for example, for skin. And then we can set the hemoglobin and the melanin value. So the hemoglobin is your blood in the skin, and the melanin is the skin pigment. So the more melanin a person has, the darker the skin tone gets, and the less melanin a person has, the brighter it gets. So darker people, for example, they still have subsurface scattering, but the light is getting absorbed in there much stronger. Therefore, the subsurface scattering effect is less strong. So in order to do that, we can, with the saturation, we can set how much hemoglobin we want to have, so how red the skin is, and with the value, how much melanin we want to have. Then we maybe have something like that. And then if we remember, we have here the scale. For example, if we say, okay, it looks pretty cool, but it's not very realistic. For example, for skin, we want to go much lower. Then we can change this value here and affect the radius color basically in one go. So we don't have to go in here and go in here with crazy values. So yeah, we can control it in that way. So the next way is we can multiply a certain color on top of our base color. And first I'm going to show you guys how to do that. Then I'm going to say why I'm not that much of a big fan of this technique, but I'm also going to say when I'm going to use this technique. So let's go here with the layer RGBA, AI layer RGBA. It's the most crippled node that exists in the universe, because the way how it is set up is just weird. So we turn off layer 1, because this node wants it to work from top to bottom, which every layered program is not working like that. So we want to work from the bottom to the top. So we plug in here this guy into input 8. We turn on layer 8. This one is going into the subsurface scattering radius color, and we see something already happens. And now we want to set here the layer 7. We go here for a red to start with. And here another little oddity about this node is we don't set the blend mode for this layer on this layer. Yeah, it doesn't make any sense, don't tell me. We set the blend mode for this layer on the on layer 8. So we want to tell how we are going to blend this layer down. I initially said that this is not a tool specific tutorial. This part is maybe a bit tool specific, but ignore that. So this is just for the Arnold users. And now we can set here how we want to have this tone. And based on that, we can get the radius color. The cool thing about that is we get, I would say, a bit more detail in our subsurface scattering behavior, since it takes into effect what is here in the texture as well. So wherever our texture is a bit brighter, we get a bit more subsurface scattering, and wherever the texture is a bit darker, we get a bit less, which is actually quite nice. The downside is it is very hard to control, because maybe we dial in the value in a certain way that the reds, they look nice, but then some other parts, they look a bit ugly. And when we change then this color here, this is then going to affect everything. Then maybe the red look ugly, but the green or the brighter parts, they look good. So I find it a bit of a not so practical way of working. But there are some use cases where this actually can be quite nice, and therefore I usually use a color correct node. And I'm not going to multiply the color over it. I just use that texture straight into the subsurface scattering radius. For example, when I make teeth or fingernails or everything where the subsurface scattering radius is not that skin-like, where we mimic the different skin layers. And usually the values I play around with is the saturation and the exposure. So the brighter we make it, the deeper our subsurface scattering radius is going to be, and the more saturated, the more of the color effect we are going to get. So this is a very nice method of how to make materials that, yeah, I would say are more like, yeah, teeth, fingernails, stuff like that. That is not like a skin where we don't have a layer of blood underneath. That's where, for example, I would pipe in my color texture right into the subsurface scattering radius color as well. So again, there are some different ways of how we can utilize all of those values. That's why I thought I'd try to explain to you guys what those values are doing. Then you can figure out yourself in what situations you're maybe going to use what technique, or how you're going to alter those values. So, and just to complete here, when we turn the anisotropy down, we see the subsurface scattering effect is getting a bit less. So the light exits a bit faster. If we turn it into a positive one, we see there's a lot more going on with subsurface scattering. So it travels a bit deeper. It's not the exact same like the scale. Again, this is a bit of a more complex thing what is going to happen here with the lights inside of our surface. It's okay to have it at 0 and play around with the positive or negative ways and get a bit, yeah, your experience with that as well. Okay, this was it. I hope this was learnful for you. If you didn't understand something, then feel free to put it into the comments, or if there was something that maybe I did a mistake, feel free to let me know in the comments as well. Or if you have any wishes for topics, then feel free to put it into the comments as well. So then I wish you guys happy rendering and see you next time. Bye bye.